In this session, I am explaining simple queue or linear queue, how it will works and its operation in detail. What is this? I am explaining. Queue data structure using array can be implemented as follows. Before we implement actual operation, first follow the below step to create an empty queue. Step 1, include all the header files which are required in the programs and define a constant size with specific value. This is common in the programs what we are doing previous also. That is, header respective header file should be included in the program, and size is nothing but the array size which we should be included. That means the size of an queue. That means it may be as our wish. Next, declare all user defined functions which are used in the queue implementation, because here we need, that is, for example, enqueue and dequeue, and another front and rear. Next, create a dimensional array which above defined size int queue of size. See, this is queue is a variable and the size is the size of a queue. Next step, define two integer variable front and rear to point out how it is moving, and initialize both with -1. Initially, I am initializing a front equals to -1 and r equals to -1. Next, in next program, what I am doing, next after front equals to -1, I am assigning front equals to 0 and I will keep rear as it is -1. In next programming, I will explain how it will works in detail. That means in next slides. Then implement main method by displaying menu of operations like make suitable functions call to perform operations selected by the user on queues. Now here you can see how it will work. In a queue data structure, enqueue is a function used to insert a new elements into a queue. Now you can see this is a queue. I have taken queue size equals to, here in previous slide I have shown that size. Now I have initialized size equals to 4. Queue of size is what? Now it is 4. Now in a queue, the new elements is always inserted at rear position, that is r equals to -1 initially. Then what I am doing, I am incrementing r equals to r plus 1, that I am moving r equals to 0, because in this position you can observe that f equals to r equals to 0, that is value can be inserted at f equals to 0 and r equals to 0. That means front and rear are 0 initially. Here I am inserting an element, that is, this is the meaning of this one. If in a queue the new elements is always inserted rear position, the enqueue function take one integer value as a parameter and insert that value into a queue, this value. Next, what happens? We can use the following step to insert an element into queue. What is the steps? Check whether queue is full, that is rear equals to size -1. When r is comes to here, see here, if I try to insert, what happens? What is size here? I have told that is 4. Now -1 is what? I am minusing the one value in 4, that is equals to 3. Size equals to 3. Rear value is what here? 3. When 3 equals to 3, what happens? It is full. If it is full, what happens? Then display a queue is full, insertion is not possible. This is common sense. That means when there is no space, if you try to insert, what happens? There is no space to insert a value, or it will show in a message queue is full, insertion is not possible, and terminate the function. Next step, what? If it is not full, then here you can see if it is not full, what I am doing, as I said, rear equals to rear plus plus, that means rear equals to rear plus 1, and set queue of rear equals to value. Now I am setting this value r equals to 3 and I am inserting a value into queue of rear, that is q of 3 equals to 40. In a queue data structure, dq is a function used to delete an element from the queue. This is an elements where you can delete, that is dq. Sorry, this is the function. In a queue, the element is always deleted from front end, that is when f equals to 0 position, and the dq function does not take any values as a parameter. We can use the following step to delete an elements from the queue. See, before deleting, what I should see, if it is empty, can I delete the element? No. For that reason, what I should check whether the items are there in a elements or in a queue or not. For that reason, check whether queue is empty. Front equals to rear. This is front equals to rear. When front equal, here you can see front equals to rear. When it is front equals to rear, queue is empty. Deletion is not possible and terminate the function. Next, if it is not empty, then increment front value from 1, that is front plus plus, that is front equals to front plus 1. After deleting, what I am doing, I am incrementing in a f element. See, here you can see initially f equals to 0. Now I am assigning f equals to f plus 1, f equals to 0 plus 1, f of 1, this value. If it is not empty, then increment front value by 1, front plus 1. Then the display queue front as deleted elements, that is which is deleted. Then check whether both front and rear are equal, because when it is equal, what happens, it is there is no elements is there to delete. Then I am initialize here. If it is true, then set both value rear equals to minus 1 or equals to minus 1 when f is greater than 0, and I am initializing f equals to 0 because I am reusing this value. Otherwise, if I not declare this value, what happened, this 4 space is get wasted. Display function, you can see what is display. Display is nothing but to display the elements or content which are in the queue. What are the steps we are using? Check whether queue is empty, front equals to rear. If it is empty, it will display queue is empty and terminate the function. If it is not empty, then it will define an integer variable I, because here in size I am taking from 0 to 3 as in previous. For that reason, I am taking a variable I equals to 0 and set I equals to front plus 1. That is initially I am assigning I equals to 0, then I am incrementing I equals to front, that is 0 position, 0 is in front position, and incrementing 1. After that, what happens, display q of y value and increment I value by 1 I plus plus. Repeat same until I value reaches to rear, that is I is less than or equal to rear. Here you can see the function programming. As previously I have said that we should declare the header file. I am declaring the header file. Now I am initializing the values for size equals to 10, and I am calling 3 function. One is enqueue and another one is dequeue and another one is display. That means to insert, delete and display. Now queue of size. What is the queue of size? 10, because size here is 10. That value is initializing front equals to minus 1 and r equals to minus 1. Next, I am declaring main function. Main function, I am taking 2 variables, that is value and choice. I am using loop because there are 10 values. For that reason, I am using while loop. You can use any loop, that is for loop, or which is convenient for you, do loop, do while loop or while loop. For me, it is convenient. Therefore, I am using while one. I am printing a function menu. I am taking 4 options. One is insertion, deletion, display and exit. Next, I am entering your choice. That is, I am requesting which choice that means you want to insert, delete or display. These choice should be entered by the users. I am scanning that one. I am using a switch statement to operate these four values. Here in case 1 what I am doing, I am taking NQ, that means inserting a value into a queue. If after performing it will get break means it will come out of this loop. If he press anyone press 2, then this DQ is operated. After performing DQ it will get break, and next display function is operated. If he enters a three options, then it will break. Next after that there is a fourth option, that is exit 0. That means you should do, if you want to come entirely out of the loop, then it will take. That means if you not press any of four these options, then it will print a message, wrong selection, try again. Here you can see. Now I am explaining in detail how NQ works. Here void NQ int value. Here I am taking a value to insert a value into a queue. Now if rear equals to size minus 1. Initially I have told that before inserting any value into any queue, whether I should check the queue is full or empty. If it is full, what happens? If it is like this, what happens? If I try to insert any elements, it will show that queue is full. Insertion is not possible. If this condition comes means here I cannot insert any elements. For that reason I am checking. In these conditions you can see here this is empty. Therefore it will skip this element and it will move to the front. Front equals to minus 1. Yes. Now what I am doing? Front equals to 0. I am initializing f equals to 0. Next, what happens? Here f equals to 0. Now r equals to minus 1 is there. Now I want to increment. R equals to r plus 1. Here r equals to minus 1 plus 1. What is the value? Now r equals to 0. You can see here f equals to r equals to 0. Now q of rear. Q of rear is what? Here it is 0. That means in 0 position I am inserting a value. That value is nothing but 10. After this, what? Once again it will come into a loop. It will check rear equals to size minus 1. Here rear value is what? Here it is 0. Now I am incremented. Now it is moved to the 1, size minus 1. Here what is size? In this program I have taken 10, but in a diagram I have taken only for 4. 4 minus 1, 3. That is 0 equals to 3. No, condition false. It will come here. This is also false. Then r equals to r plus 1. That is it will move to 1 position. R of value equals to here. That is q of r is 1. The value is 20. Next, similarly, third value, now r equals to 2, 30 is inserted. Next value is 3. That means here r is incremented. R equals to r plus 1, that is 2 plus 1, r equals to 3, and item is inserted is 40. Then after that, if I will try to insert in a next position, here r is equal to 3. Now if I try, if it is get incremented, rear equals to rear plus 1, the rear value is here, it is 3 plus 1, 4. When it is 4, you can check if 4 equals to size minus 1. What is this size minus 1? 4 minus 1, that is 3. 4 equals to 3? No, condition false. Then condition false. Here 3 equals to 3. 3 minus, here 4 minus 1, that is 3. Condition true. Therefore it will print q is full and insertion is not possible. This is inserting an element into a front hand. Now I am explaining how element can be deleted. Before deleting also we should check whether it is empty or not. If it is empty like this, you cannot delete any element from the q. That is, when f equals to r equals to 0, you cannot delete. That means it may be 0 or it may not be 0. When if it is f equals to r equals to 3, then if the condition is true, what happens? It will print q is empty, deletion is not possible. Otherwise, it will delete an element and it will increment f into a one position. That means here you can see f equals to initially 0, 1, 2, 3. Here r equals to in 3 third position, and this is the another element. Now I will delete one element. After deleting, what happened? Front plus plus. That means front plus 1. I am incrementing one value. Then f equals to 0 plus 1. F equals to 1. Now it is moved to the first position. In this, I am deleting once again 20. Next, what happens? F equals to f plus 1. Here f value is 1 plus 1. Now it will become 2. Now after that, I am deleting 30. Next, what happens? Next, r equals to 3. That means here after deleting, you can see here after deleting, what happens? R plus 1. R plus 1 is 2 plus 1. That is 3. That is third element. Now what happens? I am deleting fourth element and I am incrementing r, because here you can see r equals to r plus 1. F equals to f plus 1. F equals to f plus 1. What happens? It is incremented. When it is here, you can see when it is f is greater than r, now what I am doing? I am reinitializing f equals to 0 and r equals to minus 1. That means to reuse this space, for that reason I am using f equals to 0 and r equals to minus 1, and these values can be reused. The here initially in previous slide, what I am doing? To an insert element, I am incrementing rare element, that is r equals to r plus 1. That is in NQ. In DQ, what I am doing? I am deleting an element. Now I am incrementing front end, that is front equals to front plus 1. After this, after deleting all, when f is greater than r, what I am doing? I am reinitializing f equals to 0 and r equals to minus 1. Now display. In the display also, you can see if any elements are there, then I can display. Otherwise, what it should show? Q is empty. Same thing that is done. That if r equals to minus 1, if it comes here, what happens? It will show Q is empty. Else it will print for int. I am declaring a variable I, because from 0 to rare 3. That means from front end to rare end, I am incrementing that one. For that reason, I am taking I equals to front. What is the front value here? It is initially 0. Now what happens? I value 0. What is rare here? You can see r equals to 3. 0 is less than or equal to 3. Yes, condition is true. It will print q of 0. What is there in q of 0? It is 10. That element is printed. After that, what is there? I plus plus. What is I value? Here 0, because here you can see I is initialized to front. The front value is 0. Now I is 0. 0 plus 1. 1. It is moved here. Here you can see. Now what is the value of 1? In that it is 20. Similarly, I equals to 2. That means I plus 1. 1 plus 1, that is 2. That value is 30. Once again it is moved to the another or incremented I value. I equals to I plus 1, that is 2 plus 1. Here you can see I equals to 3, that value is 40. But what happens here? You can see I equals to r equals to 3, that is here it is same. That means front end is incremented, this value is incremented and it is assigned here. But front initially it will be 0, now also it will be 0. Only incremented value is I. Now you can see here I equals to r equals to 3. That means I am printed all 4 values, that is 10, 20, 30, 40. These values are printed in the here. You can see the output menu has in Previous slide I have explained 4 options. Enter row choice. Here 2 is the option he has entered. The deleted is 10, and same operations are performed. Thank you.